It's late, but that's okay. We're going live on, I just added Twitter to this whole feed too. All right, so it says we're streaming, so I guess we're live. I don't know. Let's double check. Yeah, LinkedIn just sent me a message. All right. Well, today is the first day of Energy Month, David. Self-declared.
I feel energetic already. How about you?
You feel energetic? Do you have a meter? Do we have a meter on you?
I can't talk about that.
Well, you know what? I mean, if you have an iPhone, you probably have, how many steps you did, right?
That's true.
Huh?
That's true.
What's the accuracy
what
of that?
Called? The stepometer? Is that what it's called?
Is it a stepometer or a pedometer or
pedometer sounds about right.
That sounds better. Pedometer, not petometer.
All
right.
Not pet.
Well, so we are we're shifting gears, coming off of a safety month and moving into an energy. And I did a search this morning. Did you know that today? Hold on. Okay, June. Hold on. You holding on? June is National Give a Bunch of Balloons Month. Okay. Okay. So look at this. Close that. It's National DJ Month. It is African American Music Appreciation Month.
Sure.
It's the National Zoo and Aquarium Month, so you got to go visit a zoo or an aquarium. Hey,
animals are great.
Ryan Jackson in the house. So Ryan, we're having a discussion. We're declaring June a National Energy Month, but I don't know how to make it official. But I'm looking at all of these other national. It's National Fresh Fruit and Vegetables Month. Do you know that?
I did not know that.
Well, you do now. I mean, there's a whole list. There's a whole list. This is National Headache and Migraine Awareness Month.
That's true.
And
so who do we need to get in contact about National Energy Month?
Well, I think, and I'm doing my research on that. I'm doing my research. Okay. So we are going to. I found a website that you can submit, but it said you can like submit for a national day. I want a month. I don't want a day. I want a whole freaking month. So we got to do some research. George, good afternoon, brother. We got George. We got Ryan Jackson out there. So today, though, we're going to kick off Energy Month. So all the month of June, we're going to be talking. Yeah. Okay. Ryan's going to contact all of his people. And I think, well, here's what we'll do, David. You know how this all starts. Word of mouth.
That's true.
Next year, what we'll see is we'll see NEMA or we'll see some other organization advertising June is National Energy Month. And we'll just start the trend.
I love it.
I love it
first,
too.
It looks like it's going to start out in Omaha, and then it's just going to start metastasizing to the greater Midwest. And it's going to be great. Yeah, absolutely.
Oh, man. Yeah, so June, and that's right. We can connect June, like Tamaki says, June with the jewel, for energy, and that there's a relation there. I love it.
Absolutely.
I love it. So we're going to talk about energy and the thought process. We got Nihad, we got Tamaki, we got Felix Sandoval in the house. So it's going to be standing room only for this discussion. So here's the thought process. This session, I would love to lay down sort of a foundation to understand why is it important, who might want to do energy management, why we use energy management. We'll touch a little bit on what different codes and standards might be involved, but we're going to have a special session on that on Thursday with Mike Stone talking about energy codes. But I want to focus a little bit on some of the basics. This is right in my wheelhouse. When I started Eaton, this is where I was at. I was knee deep in energy management. I was product manager for communication hardware and software. We had Dan Ellis was our metering product manager. I don't know if you remember Dan Ellis, right?
I've heard good things. Yep.
Oh yes, Dan Ellis is a great guy. We had Dan Ellis. We had Chris Walker was involved with the power management. We had Brian Brickhouse was our VP GM for power
Wow.
management. Yeah. So we did a lot with energy management and working with large companies. But now, David, I want to talk too. I think you have the residential, you have the commercial, and you have the industrial, and all three of those are going to be different. Solutions are going to be different. Reasons that you'll monitor and will be different. So, and then also accuracies too. So let's just. I know we had some. I had a plan of attack. Let me bring up my little Word document. So we're trying to get everybody out there. We're trying to get a little bit more organized. So and David keeps telling me you got to use that Word document in Google Docs.
There you go.
You're teaching me. You're teaching me. You know, I learned
So I
two.
guess
I learned two
with
things.
that.
I learned how to go live on Twitter. So
Okay.
there's a right now there's a live feed going on Twitter. So we're streaming to Twitter, Facebook, LinkedIn, and YouTube. And I
This is
learned
great.
about LinkedIn stories.
Okay.
Do you know what a story is?
Uh, Tell me what a LinkedIn story is.
So the way I have it, you get you go to you can only do it on your phone, and if you go to LinkedIn, across the top, you got to update your app. You'll see different stories. So I could say add to my story, and if I can create a little short video. I think 30 seconds is all you get, if I'm not mistaken. I think so. You got to get it like within 30. I think you can go longer, and then it just becomes multiple stories. But
Sure.
but then they last for 24 hours and then they disappear. So I don't know. So I'm playing. It's like dangerous.
This is good. So this is kind of like whenever the president comes on and makes a national address, like every channel, YouTube, LinkedIn, Facebook, Twitter, everything is now on Tommy D. And so we can all learn about National Safety Electrical Month, I should say. And so we can really get this pushing because we have all channels going at once. This is
Yes,
great.
absolutely. So let's talk about the first. When we think about energy and energy usage, Santiago in the house. Good to see you too, brother. So when you think about energy usage, David, why do you think somebody would want to know their energy usage?
So I'm glad you asked, Tom. Um,
Put you on the spot.
yeah. No, so I would say, I as a homeowner, right? Some people find it very much useful to know their energy usage, and actually to the point where, they track their stuff, and they look at the usage over months at a time, over year on their electrical bills and stuff like that. But I would imagine if I was a larger entity, like some type of industrial presence or a heavy commercial presence, I would want to know how much energy I'm using, and which applications I'm using it in, so I can possibly cut costs and figure out different ways of being smart of using all of that energy, because that would probably be one of my greatest expenses whenever running that business.
Yeah. So if you really think about it, it does. The bottom line, what motivates all of us, right, is the almighty dollar, right? So how much am I spending, even from a residential perspective, how much energy you're using in your home? I would argue. I think when I was a kid growing up, if my father had an energy monitoring system in the house. I mean, it was like you left the bedroom light on, you left the hallway light on. We were always worried about that energy usage. Um, but and there might be some homeowners who are very concerned about about the energy usage in a residential application, and I agree. But there's only so much you can do in your own home other than shutting lights off and things like that, and maybe running your temperature in your home at different degrees, understand the energy usage and profiles of different things that you're doing in your home. uh, and so there's that angle from a residential perspective, but it really comes down to I think from a residential perspective you get both both the cost aspect, but I think it's an awareness thing more so. In a residential, and you know, I can tell you how much energy, how much current. In fact, I'll tell you that right now. Like my system right here is pulling. I got these small little metering devices, and I can tell you like my front lights and my back lights. I'm going to turn on my front lights on the house. Actually, the back lights. I just turned my back lights on. So these are like little fluorescent lights outside.
Okay.
I'm
All right.
pulling 1.51 amps, so 92.38 watts. Okay. I'm pulling just over, it's on a 20 amp circuit too. And that's the only thing on that circuit. So 1.47 amps, that's my back lights. My front lights are pulling, no, those are LED. I just updated those to LEDs, 1.1 amps. Okay. So, but if you think about what is that, when I look at knowing how much current I'm pulling, knowing how many watts I'm actually using, it'll help me make a decision at the house on how long I run them, and also if it's even going to make a difference, right? We could decide I'm only going to run them for 2 hours every night instead of 4 or 5 hours every night. But in reality, it may not even impact your energy bill, right? Because it's so low of a usage. Well,
Sure.
But to your point, when you start getting into commercial and industrial, there's an entire different twist, because now that can translate into some serious bucks. We got David Shapiro, we've got Santiago and Comfort. Old remote control versus nowadays sensors. Go and change the TV channel. Go and shut down the light. Yeah, so that's right. Santiago brings a good point. So just like what I just did, I used my phone and I turned my front lights on and I turned my back lights on, right? I can turn on my system down here. I can turn on the lights in my basement. So for me, remote control is more important. And then if you left the lights on, I can put them on a schedule, so I don't have to turn them on and off. They can be placed on a schedule. And if I want to change that schedule and see what that does to my bill, I can do that, right? But when it comes to commercial and industrial, when I was in that business heavy, we did a lot of energy billing because in some cases they were sub-billing. Okay. So like, for example, I'll give you an example. We did a bunch of airports, and the airport would get an energy bill. And let's say that you owned, what kind of fast food place would you own? What do you look like? Are you a Burger King guy, a McDonald's guy?
If I had to choose a fast food joint to own, I would absolutely own a Chick-fil-A.
Oh, Chick-fil-A. Okay.
Oh yeah, absolutely. I mean, if we're going for the best here, might as well.
Okay. You're a Chick-fil-A, and then I open up the Permanis restaurant in the same in the same
Okay.
airport. Okay.
All right. I didn't know if Permanis was fast food, but I'll allow it. That's good idea. That's actually a good point. Why isn't there Permanis in Pittsburgh Airport?
There is.
How have we there's a TGI Fridays.
There is a
Permanis?
Permanis in the Pittsburgh Airport, and you know what? This is grounds for separation from Eaton. You know that.
Hold on a second. I don't know if that's true.
It is true.
I know there's a TGI Fridays. I know there's like little sports bar-y things. I don't know if there's actually a Permanis there. This is. When was the last time you were at the Pittsburgh Airport?
What?
When was the last time you were at the Pittsburgh Airport?
Well, it was over a year ago. Here.
Saying.
Okay. All right. We're going to settle this one once and for all.
Let's do it. I could be wrong about this.
You could be. You are wrong. Permanis.
Airport?
Welcome to Permani Brothers at Pittsburgh International Airport. Currently located at Airside Central Core between terminals B and C. I could tell you that exactly where it's at.
I have no recollection from this.
Ryan
I
Jackson.
no,
Ryan's going to be in the Pittsburgh. Where are you going to be at, Ryan? You got to let us know. I'm going to be here, brother. Let me
yeah,
know.
yeah, let's go. Absolutely.
Communicate, bro.
I'm in the facility right now.
He's not communicating. So Ryan, you need to, the information goes this way too, brother.
Right.
All right. So at least we settled that one.
That's amazing. I did not know that.
Oh, man, O'Day, that's just terrible.
Anyway, okay.
Okay,
I'm running my Chick-fil-A.
So I got my Permanis,
and
you
your
got your
Permanis.
Chick-fil-A, right? And what a lot of these airports will do is they'll take the energy bill and they'll monitor your Chick-fil-A, they'll monitor my Permanis restaurant, and then I get a bill and I pay for my energy usage.
Sure.
And so what they do is, and now they, in some cases, some states, oh, he's going to be in the experience center.
Right here.
Yeah, I got to make sure I'm here.
I'll keep the seat warm.
Oh,
right here.
July 23rd and 24th. Okay, that's July 25th is my wedding anniversary. So Ryan, you can buy me a drink. Maybe I'll bring my wife.
Everybody on the call, just come to the Pittsburgh Experience Center here on July 23rd and 24th.
Bring them on in.
We'll have a live event.
Yeah. So here's the thing. Some states do not permit you to rebill. Okay, there are some laws that say you can't, like I couldn't try to make money on my bill, right? I couldn't say, look, I'm going to, let's say that you Chick-fil-A, you used X amount of kilowatt hours, and I can't make money on selling power to you. Okay.
So I want to make sure I'm hearing this correctly, because power is a utility and only certain entities are able to sell power.
Yeah.
So whenever you have an apartment in the Commonwealth of Pennsylvania, you either A, sign up for the utility yourself, or B, get into an apartment where the utilities are included. You do not owe your landlord for the power. You either pay the utility bill or you pay it through some other way of rent. Does that sound right?
So I've seen that done in various applications, not even from a resident. I'm not sure about a residential, but a commercial applications. Okay. That's the one I'm most familiar with, where they'll have say it's a strip mall, and the owner of that strip mall gets one energy bill, and what that person can do is allocate the energy to each tenant. Or that person, or they could sit down and say, look, I know my energy usage for this strip mall is X, and I've got 5 organizations. I'm going to divide that by 5. And then everybody pays a share. But if your Chick-fil-A is using nothing but electric ovens, and my Permanis is using nothing but gas-fired, why would I have to pay the same as you, because you're a big, heavy energy user, right? So
I think you should have to flip the bill as well.
I know you do. I know you do. So here's the concept is, now you got to be careful, because I can't, as the owner, in like I say, you have to be careful of local laws. I may not be able to bill you and actually say, you know what, I'm going to put these meters in, and I'm going to charge you guys, an extra $100 a month for my services, and now I'm making money off of this. You in some cases, you're not allowed to do that. You have to simply allocate the cost for each of those, right? And then you have common areas you have to think about. That how do you divvy up the common areas? So what you get into, David, is in those commercial applications, what I've historically seen is when you have a facility like an airport or a strip mall, or like the Mall of America, right? Where they charge each of the tenants for their specific energy usage. And that's purely just that helps the tenants to make sure that it's fair, right? If you're like you say, if your Chick-fil-A is all electric ovens and I'm gas and I've got a very low energy usage and you're huge, I don't want to be stuck with your burden and say, hey, you chose to use electric ovens, then you're going to pay for the extra energy, not me. So for that reason, you'll see sub-metering going on.
So I have a dumb question for you
Yeah.
before we move on, if you don't mind.
Oh, I know you're going to
So
have
let's
many of them this
say,
session, right?
oh yeah, yeah, absolutely. So let's say, I have a multi-family apartment building. Let's say it's 12 to 20 units, something like that, right? Um, so if I have, why would I go with something like a meter stack and a meter pack, stuff like that, compared to some of the other different metering entities that are on the market, like some of our power breakers that also do metering?
So in a residential type of application, I don't think you're going to see this type of sub-metering going on, because from a residential, to your point, when you have a meter for everything, that
Yep.
tenant is going to call the utility, get it turned on, and they're going to deal with the utility directly.
I think that's it, right? The
Right.
utilities have an approved means of doing this, and some of the other solutions that include metering just are not on those approved books, I would imagine.
Yeah, exactly. Now, you could meter your own usage to try to govern your own habits, right?
Sure.
But the facility, the owner of that apartment complex is not going to be divvying out bills to the tenants, because each tenant has their own meter,
Got it.
right? Now, what the owner might do is say, "Look, I've got a lot of common area, and you might have each of the tenants pay in to cover for the, what do they call that? Like we do it here in my complex that I'm in. We just sent a check in. It was the for the like
Like a general?
yeah, it's I forget what they call it. It's a you have a man. Somebody out there's got to remember these things. But so we pay a the group for the group, and which covers there's lights that go into our in on our road, right? And
Are
those
we
take.
talking about like a homeowners association
Yes,
situation?
thank you.
Okay.
Like a
All right.
homeowners association, right? So they'll do the same thing in these larger complex, because you have energy usage in those in the common areas. You've got snow removal. You've got a lot of things that they pay into association fees. And in some cases, the association fees might include some dollars in there for the energy usage for whatever it is in the common areas, right?
Sure.
But but and that might be all a part of those association fees. But outside of the residential and even those types of commercial, when you get into a place like an airport or a shopping mall, those installations will allocate the energy, because they don't have a bubble meter for every store inside of an airport, right, or inside of a shopping center mall. They've got a huge service, they do power distribution, and the owner of that mall will elect to possibly meter, not a code requirement. They'll meter each of the tenants and then charge them for their energy usage.
Got it.
That way it's fair, right? And I've done a lot of those. I mean, we did Air Force bases too. I mean, even in an Air Force base, they would allocate the energy for the different divisions and groups within that base. They knew how much energy each of those different facilities used, and then they allocated that, because here's what it does: it drives behavior, right? So now, if I tell you you're Chick-fil-A, and I tell you, here's your monthly bill, and it's like, let's say that let's just say you and me are the only stores in this shopping mall, and the total bill is, say, $100,000 a month, and you're paying $90,000 and I'm paying $10,000, and you
Yep.
go, how the heck is he getting away with 10,000? Well, it's the big electric ovens that you use. You may start to say, maybe I'll try an alternative method. What's the price of gas? How much gas would I be using? Or maybe, and this is, maybe you'll cook all your food at night and then you'll just microwave it in the morning.
I
Okay.
don't like the accusations that are being passed from one restaurant to another right now.
Hey man, I'm in competition with you. I want people to come to Permanis. Okay.
Playing dirty.
I'm playing dirty. But that's what happens, in what you do is you drive behavior. Okay, so in those commercial buildings, and in the commercial buildings, I think it's more associated with fairness to everybody. So you're not paying more, or not paying, you're not paying, in some cases, you may not be paying your fair share. And in some cases, you may be paying more than your fair share.
Sure.
Now, when you get into industrial, what I learned there was that, let's say that you make widgets. Let's say that
I do.
you make, let's say you make widgets.
I do.
Let's take your product line. Let's take a product line, right? Let's take
All right.
a product line that makes different meters. Okay, you've got the IQ products, you've got whatever, these IQ 3000s, all these different meters. And let's say that in your manufacturing facility, you have a line for each of those meters. You could monitor the energy for each of those lines, and you could know exactly how many dollars it takes to build X amount of those meters. And then you could say, it costs us, I don't know, $5 a meter just in the energy usage, right? So you could allocate that. And then here's what they used to do, and they probably still do it. Like we did a lot of like automotive manufacturers and other large people like that would make like transmissions or vehicles. They knew how much energy it cost to make a transmission, and then what they would do is they would allocate that energy, and that would be in the budget for a department manager. And they would say, okay, your energy usage on a monthly basis is $5,000 or $20,000 for the energy bill. In your budget, you have $20K. Right now, if you come up with a practice that would save money, and let's say that your bill was only $15K, the extra 5 goes right back into your budget, and you can use it for something else.
Sure.
Okay, now what's that going to drive is behavior from each of those different product lines to sit down and say, hey, if we save some money on our energy, let's get creative here. What's driving our energy bill so high? How much are we using? And can we do some cost outs on from an energy perspective? Then you'll have a little bit more money to play with for other things. But the first thing you have to understand is, what is your energy bill? Right?
Absolutely. I mean, the first thing to making any type of decision is knowing the situation you're in at the moment, right? And so particularly for commercial and industrial, asset allocation is huge, right?
Absolutely.
Resource and asset allocation is the name of the game whenever it comes to particularly facilities managers, right? Which is what we're talking about, I guess, at this point, right?
Right. So, and even in a residential, you've got to understand your energy bill. What are you paying the utility every month?
That's true.
You know, and it might be that you might sit down and look and say, hey, I'm paying $90 a month. Are you going to try to save money? Well, heck no. I mean, you're at $90 a month. I mean, if you try to squeeze anything out of there, what are you going to be at 85? So you save $5 a month, and then in a year you saved $60. Whoopee ding ding, right? So,
but to make your point, I know that because I know how much I'm using every month. I know how much
right.
it's costing me every month.
It's exactly
I'm
right.
able to make that decision for myself after the fact.
Right. You don't want to install
Sure.
a bunch of meters in your house and then say, oh man, you know, I just spent $5,000 on meters on my house, but I'm only going to save $5 a month. It's going to take me forever from a return on investment perspective to make any money on that, or to even break even in that investment.
But those sales on my product line of meters, that probably helped at some point.
Yeah.
I just sold like 5 or 6 more meters.
That's right. That's right. Yeah, it depends on what side of the fence you're on.
Yeah, eventually I'll get back that money.
That's exactly right. So Robert from Omaha wants to know, I guess he has a problem with transmissions falling out of his vehicle. So I don't know, Robert.
Oh.
And he says in some facilities they may measure equipment usage. Atif says, is there any percent or limit of connecting energy from solar systems to utilities? Okay, so there's another reason for monitoring and energy management is to understand what you're putting back on the utility and what you're consuming. And there are each utility, and we're going to have Tim Crawshaw. I got to contact him, make sure we're still going. But Tim is going to go live with us and talk about the interconnection. He's from a utility. Tim has a utility background. But I know on like in our experience center, we can't put stuff back up onto the grid, right? So we're not allowed. So to answer a Tef's question, yes, there could be a limit, and it might be that you're not allowed to put anything onto the grid.
Right.
For your utility may tell you, ain't gonna happen, right? So you got to use what you manufacture locally from an energy perspective, and if you're not using it, then you better store it for later use, but you ain't putting it up on the grid. So that's an important aspect. Usage calculations for PV, solar, and energy storage capacity. That's right. So Robert from Omaha says you got to do that calculation to understand. Now, here's another reason. So we're talking about managing it and monitoring it, right? So we know that you first got to understand what is your usage. And then if you want to manage it, then you can try to allocate it however you want to allocate it. It might be, from a commercial perspective, you might just be saying, look, Chick-fil-A is going to get their bill, Permani's going to get their bill, Burger King's going to get their bill, and the Dick's Sporting Goods is going to get his bill. And then, or you might sit down and say, look, I'm in a facility that makes widgets. Department A is going to get a bill. Department B and C are going to get a bill. Marketing is going to get a bill. The plant manager is going to get a bill. Okay. And the plant manager might say, hey, I want sub-metering because the plant is making what do you call it? Transmission A, B, and C, right? And he wants to allocate the energy for each one of those because they want to institute the right behaviors from a manufacturing perspective. But so your reasons to monitor will vary. Now, another one, I visited a grow facility in Pittsburgh here. And their challenge, I love this, they're growing. I mean, literally growing, not growing plants. They're growing in their business. And so the facility manager says, he says his challenge is he's not sure of capacity. Right? So
tell them capacity has nothing to do with this and the inductive stuff. We can work that out, the power quality stuff. You don't have to worry about capacity.
yeah, don't worry about capacity. We'll just throw some power factor correction caps in there. You got a lot of capacity.
We'll be fine.
Yeah. But what his question was, he's like, he doesn't know how much energy he knows from his bill, but he's not quite sure on a day-to-day basis. And then how much can he add, right, to his facility before he needs to get maybe another service or whatnot. So he's got a complex system, and they need to have more awareness of their energy profiles.
Sure.
And then Ryan's saying the International Energy Conservation Code requires individual metering at multifamily dwellings. That's right. Any idea if that is being pushed for commercial? No, I don't think so, Ryan. I've not seen anything like that being pushed from a commercial application. Because remember, in a heavy commercial, like say, take an airport for example, right? I mean, there's so many different uses of energy. I mean, another thing that we've done at airports, for example, say American Airlines has 4 gates. They could monitor the energy usage of those 4 gates and charge and give American Airlines a bill. Say, here's what you're being allocated. And then they can also allocate all the common areas to all of the airlines, but you got to make sure you're monitoring everything.
Sure.
If you're going to start doing that, then that's when it starts to add up. And then you say, what's my return on investment? And you're not allowed to make money at it. That's the other thing. Your return on investment might be a happy customer who doesn't leave.
Sure. And absolutely. One thing that actually someone in the comments mentioned whenever they were talking about usage of the machinery, I never really thought about, that you could almost use it as a way of, I don't want to say measuring deterioration. I can't remember what the actual business term of it is, but you can measure the usage of equipment by measuring the energy that has gone through it during its lifetime. and
Sure.
kind of start to understand, because even I think our circuit breakers on the power defense side, they measure its own deterioration with the battery health to let you know when it's the best time to replace your circuit breaker. And so I wonder, I mean, this might be something that we already offer and whatever, but this might be a good way of measuring when your equipment is going to be coming up on needing replacing soon. Just another way of measuring that, because you could probably do that a couple different ways, but measuring the energy might be another way of going about it.
Yeah. So, for example, on my HVAC unit, I have a geothermal system, and we couldn't figure out what was going on. But we found out that my blower motor, uh, I think it was the bearings that went. It just was not turning. But if I would have looked at the energy usage of that blower motor, I would have seen the profile going up, and I would know that there's something going on with that unit because it's working harder, it's pulling more current, it's using more energy to get less work done because it wasn't my RPMs weren't up. Here's another thing: Schriever Air Force Base. Love this one. This was such a great example. Kevin Phillips, good guy. Kevin, and this was back in the '90s. I supported the Schriever Air Force Base, and I went out to visit them. I always thought it was. I couldn't wait to go to an Air Force base. I'm thinking, boy, what type of airplanes were going to be there? And then I found out that it's just like a big data center. It was our hub for communications, and there was no planes. But this was what kind of cool. How he used his power monitoring system in that Air Force base. They had what they called pods, and I mean the pod was a big room that had nothing but computers in it, and there were seats for different people who might have been flying drones. They could have been managing the video for battles, communications, all this good stuff. And it was heavy energy usage. And the way they laid out the HVAC in those rooms, the under the floor was like a return air duct. And so you had the air coming in on the top, and then you had the under the floor as a return air duct. So, and what he knew was that if you lifted, like, I think it was like 4 tiles, if you lifted 4 tiles or more within so many minutes, you lost control of the heat in that room.
Wow.
Or your system could not make up because you lost so much heat, it would take too long to recover, and then you were jeopardizing the integrity of the electronics and whatnot. And it had to be at a certain temperature. So what he knew was he was monitoring the blowers, okay, and the usage of for the HVAC in each of those rooms. He knew, based upon, he had set alarms that when the energy went above a certain number, he knew that somebody had 4 panels or more open. And then he would get on the phone and tell them, put one of those panels back, or make sure you only have 3 panels open at any time. Because he said what they like to do is they would just open a bunch of panels because they wanted to see everything. And then they would get in there and work, and he'd say, no, you can't do that. And then he knew that if it lasted for so many minutes, that he had to tell everybody in that pod to move across the hallway to another room, which was a exact duplicate. And they had to vacate that one, go into the other one while they got the other one back under control.
Wow.
Yeah, so there's a lot of things that you can do with monitoring, but you have to understand your goals. So the first part of anything, the first part of our energy journey this month is understand what it is you want to get out of your system, right? What is your energy use footprint? If it's energy reduction, what are your targets? How much do you want to reduce? What energy is being used, maybe in either by departments or by facility. So you have to understand that. And then, okay, so now, then the other thing is, okay, and there was a very large industrial that was a customer of ours, still is a customer of ours. There's this thing called peak demand. You know what peak demand is?
Peak demand.
Yeah.
Is whenever the demand is at its peak.
Okay. Do you know why is peak demand significant?
I would imagine it is the during a particular time of day, right? The way I always kind of thought about this was just air conditioners. Whenever it gets very, very hot in midday in Midland, Texas, right? Everyone has their AC on,
Mhm.
and everyone has their AC on at the same time. And so you essentially have to build the system to where it is at that peak, and so no one loses all of their energy all at the same time, right? If one breaker trips, then everyone loses it. Now you have some serious reliability issues. And so, have I hit what you were looking for here?
Okay, so that's close. The other aspect
I'll
is
take close.
okay. Well, you know that's remember a demand. Let's talk about what demand is. Demand is a
Sure,
calculation. Okay,
absolutely.
so you might have a peak demand, which is based upon a 15-minute, 30-minute, 20-minute, whatever window. And
Yep.
what they'll do is they'll look at your kilowatt usage averaged over that window, or whatever the peak actual was in that window, or say for the month. Okay, say it's
Yep.
for the month, and a utility knows that. Let's say that that Chick-fil-A baby, when David Smith gets in the morning and he fires up all those ovens,
That chicken is going.
that
Let me tell you what.
that chicken is going. When he fires up all those ovens, he hits a peak demand of, I don't know, say, I don't know, 1,000 kilowatts. I mean, huge peak demand. But after everything fires up, he's really down around 300 kilowatt constant usage. But the utility says, hey, you needed 1,000 kilowatts. For that, in that 15-minute window, you needed that, so I need to provide it to you, although it happens only maybe once a day or once a month. So what the utility will do is charge you for you based upon your peak demand, because they know they have to have it ready. You don't see too much of that in a residential, because you don't see a huge peak demand in a residential home, but you will see that in a commercial or an industrial, especially an industrial facility. When
Right.
you might hit a peak demand is and this is what happened at this one industrial. They were charged, now remember, and a peak demand lasts like for a year. Okay, so and what happened to these guys, they had three different divisions within this huge facility, three different groups, and they all decided to do a test on whatever it was, and it was a lot of rotating equipment and presses at the same time. They hit a huge peak demand, which cost them, from an annual basis, hundreds of thousands of dollars. I mean, it was fun. Their energy bill was unbelievable. I mean, I was like, holy crap, right? So, but now they're stuck with that for a year because they set that peak demand, and there's no going to the utility going, oh, that was just a one-time case, we won't do it again. No, you did it.
This is your high water mark for the year.
Right, that's your high water mark for the year, exactly. So the utility knows I have to have that capacity ready for when you fire up or whenever you do that. So what an energy management system will do, with like what you see behind me with all the metering and monitoring, you can, before you do your test, stage things, right?
Okay.
So you could sit down and say, okay, David might say, okay, I know we hit a huge one, but what we're going to do, we turned on all of these electric ovens at once. So what you might do to avoid that peak demand, turn on oven 1, let it fire up and stabilize, turn on oven 2, let it fire up and stabilize, turn on oven 3. If you turn them all on at the same time, now you're going to hit a peak demand, and that's going to be reflected in your bill. And if you are in a facility like where I'm sub-metering and we hit a peak demand, and now the utility is going to pay, the utility is going to rack my bill, I'm going to allocate that peak demand charge to you and not over to my Permani sandwich plate, right? Because you were the offender that generated the peak demand. And how do I know that? Because I monitored you, and now you get punished, not everybody else. And that'll
I'm
hopefully,
not a fan of that.
You're
I
not
like that.
you're not laughing at all, right? No, you're
I
not
like
into that. Santiago says,
it.
"Do you believe at some point energy management will achieve a point like KNX, multiple inputs of information being used for multiple purposes?" I've seen that already, Santiago. I have seen um, the energy information being used. To my example with the Schriever Air Force Base, they used it to know what's going on in each of those pods. Um, in some facilities, they used it for knowing maintenance, like we just talked about, where you can sit down and say, I know a process uses only this much energy. You can do it by a process. You can do it by end use piece of equipment. If your motors are all of a sudden using 10% more power and energy, and you haven't done anything, the load's the same, but the motor is pulling more current and using more energy. It could be a bearing issue, could be an alignment issue, it could just be a winding issue, could be a lot of different things. But you've got an issue, and then you can use that for maintenance as part of your NFPA 70B program. So energy management is a lot more than just allocating costs. There is an awareness piece to it. And what you do with that, from an awareness perspective, what you do with that is really up to the creativity of the individual. So that leads us into developing your energy management plans. We already talked about it. You have to establish your goals. Are you just trying to save money? Are you just trying to allocate costs? If you're trying to allocate costs, you've got to make sure you know what breakers feed, and it might be that one breaker feeds a branch circuit that hits the lighting in the Chick-fil-A and the lighting in my Permanis, right? And so now you've got to say, now I've got one branch circuit. How many lights are on each? And you might have to divvy up a percentage of that. And with the right software, you can get it done. We had our software was, I'm not sure what, and we're going to get into it during this month, but I want to dig into the energy billing software. I know we had what it was called eBill. We had a complete database on every metering point, and then for every metering point, you could put an equation to say 50% of that goes to whomever. What?
I got there we go. The motion sensor was going in the room, so I had to shimmy. So
you had to move. Your lights are going to turn off, which is another part of energy demand load shed.
There you go. Right.
So the one of the first steps in developing your plan is going to be to establish your goals. Is it a cost saving? Is it an allocation? Is it for maintenance purposes? Whatever those goals are, you have to figure out what those goals are. Then you should do a walkthrough of the facility, right? There's like 3 levels, and I found some of this. I got a few good references. This one is Handbook of Energy Audits by Thumann, Thumann, not Newman. We're not talking Seinfeld. We're talking Thumann, Thumann, Handbook of Energy Audits. But what they described in this book was 3 different levels. Like you would do a walkthrough where you would just simply go through your whole facility and determine like any places for maintenance. You might notice that there's lights over in these warehouses that are on that shouldn't be on, and you can turn things off. And it's a manual thing. I know some facilities would pay somebody on a weekly basis to do rounds and just turn things off that need to be turned off. The second is they call it a mini audit, where you might actually take some meters, temporary meters. You might meter the feeders on your main, so you obviously you know what the bill is from the utility, how much you're using, but then what are the different feeders, and you can determine. And maybe even a department, you might say, hey, I'm going to meter various panel boards within my facility just to get an understanding, raise your awareness on your energy profiles. And then finally, you've got a process audit, which is, and that periodic you might even do it on a monthly basis. Just pick a day. You say, hey, maybe every week, every Friday or every Monday, I'm going to put some meters on, or the first Monday of every month, I'm going to put some meters and take some data. Or maybe you have a meter installed and you have to manually walk, take a clipboard and tell somebody go out, read the energy usage on each of these meters that you have. And then finally you have your process audit, which is it's constant monitoring on a 365 what is that? What was it? What do they call that? 7 days a week, 365 days a year.
There you go.
Is that what it is? Yeah. So
you got it, buddy.
Whatever, unless it's a leap year. So you have to understand, and I think what I've seen is the successful programs recognize the what your goals are, and then you can sit down and say, like, for example, what's the average energy usage for like different types of facilities, and where are you using your energy? Lighting is huge. You might monitor all of your lighting loads and determine, hey, I can make an investment in LED lighting and I'll cut my energy usage by so many percentage, and that will reduce my bill. But you've got to be mindful on power factor too, right?
Absolutely.
Because if you, and this is why it's really important to look at your bill. You've got to sit down and say, for example, and there's a, I had it, yeah, where's it at? I had here. This is from San Diego Gas and Electric. They have a how to read your bill on the website, and they'll tell you your electric usage. Like I think this is more of a residential, and then they have a mid-sized business, and then you have this is your mid-sized business. So you'll have your history, little trends. You'll have your current charges, your pricing plan, your electric meters, and all that good stuff. But here you have your non-coincident demand charges. So this is, if you read your bill and understand what you're being charged for, this will help you figure out what it is that you need to put in place. Because if you really want to impact this electric bill and you don't understand what you're getting billed for and how they're billing you, then you're starting the whole, it's like,
sure,
you're screwed, because you can't figure it out. You're not going to be able to figure out your plan. And then you have there's your capacity reservation demand, fixed monthly charge based on the number of kilowatts that you want to protect from the high price of electricity during critical peak pricing event. So there's the other thing is, if you get different rates based upon the time of day, right? You've got to know what your profile usage is. When are you using energy? Is it right in the peak? And you brought it up earlier. So you've got to figure out when am I using energy? And then can you allocate that out? Maybe you do a night shift for some heavy energy related, cook those chickens in the evening, mic them in the morning,
Make your sandwiches in the evening. I'm cooking my chickens.
Oh, no. I'm a Permane sandwich. We're custom build. Every sandwich is a custom build. Come on. And then you have your kilowatt hours you actually use during critical peak pricing. And and quite frankly, if Chick-fil-A knew how you were dealing with your business, they'd fire you. Okay.
Oh,
I'm telling you. I mean, if they catch wind of how you're cooking those chickens at night and then miking them, they would close down your business. They'd find somebody else to manage it. I'm sure.
You're absolutely right, which is why they don't do that.
Which is why they don't do that. That's right. So you have to understand your bill. And if you don't understand it, get with the utility and ask them, what does this all mean? And then you'll be able to come up with your plan moving forward. And then the next step in this picture is, and this is just me talking. Okay, I mean, I'm not the sharpest spoon in the drawer. Your next step is to, once you figure out what your goals are, then you got to figure out, what do you want to meter? You don't meter everything, right? I mean, that's a waste. I mean, I would love, and I know David Smith would love for you to put a meter on every single branch circuit, but you wouldn't typically do that. So you've got to figure out what meters are you going to put where and what functionality do you need. And accuracy, right?
Sure.
Can I use
Absolutely.
any CT on my meters?
I don't think you use any CT on your meters.
What are some of the characteristics I'm looking for? Do you know?
I do not. Whoa. You
Sorry
got some
about that.
John Denver?
No, that was WKRP in Cincinnati. Somebody from Cincinnati is calling me.
Huh.
Yes,
Can't imagine who that is.
I can't imagine. So,
Friend of the show.
a friend of the show, yes. So the other thing you got to think about, like these are current transformers, okay? And you have the voltage rating of the transformer, you have the accuracy of the transformer, whether it's a split core or a solid core, that'll impact sometimes the accuracy of it. But
Right.
the split core gives you the advantage of being able to put it on after the fact, as opposed to disconnecting the conductor, putting it through the donut, and putting it on, and hopefully you get it on right. Here's your ANSI B1 metering class. Metering class accuracy is 0.3%. 1.2% for 50. So you've got to know sort of what the ballpark is of your load to get the CT sized correctly, because you want to make sure you're accurate in the CT, and then that'll build in for the metering. And then you got to know that what your accuracy is of the meters. So if you look at the meters, they'll all start with there's your voltage, and there's your plus and minus, your amperes, your current, your watts, and you'll know what your revenue accuracy is. There's your revenue accuracy, plus or minus 0.2% per ANSI C12.20 .2 class or 0.2 class. So, and some of these, David, you depending upon where you're at in the system, you can get harmonics.
Sure. Absolutely.
Right, and that's helpful. I mean, you want to know your power quality, you want to know your harmonic content, you want to know, for example, I did an IEEE paper in Tupelo, Mississippi. We did a facility, we did a power quality study, we added capacitors, and what we did was we used our system. We had all these IQ analyzers that could capture a waveform. I could broadcast one message to every one of those devices, and they all captured a waveform at the exact same time. And I could compare the harmonic content, because remember, voltage applies everywhere, but current harmonics will change based upon the feeders, because it's the current, right? So we leverage these meters in our power quality analysis to be able to provide that real world example, real world data. So, and again, that it depends on what your goals and objectives are. And you might have a very expensive meter on the first level distribution. You might put a very, very expensive meter on very large, expensive equipment, but you probably wouldn't do that on every single feeder. Make sense?
It does.
Here's the Power Expert 3000 series. Identify power quality problems to help protect motors from damage, preserve the integrity of processes and batches. So this goes to Santiago's point of multiple reasons that you would bring back data. Meter what you need. Client asking something that and having to tell, sorry, you can't do that if you don't meter this and this and this. Do you believe it? So Santiago, you're right, but I mean, here's the thing. It's a challenge to determine at the get-go what you're going to meter, because here's the thing. You have to be able to say, I'm going to show a return on investment. If I put one of these meters on every branch circuit, I could go broke just in meters. I mean, I would love that. I mean, I wouldn't love to see you go broke, but my product line would go, hey, we got a huge order. Needless to say, the customer didn't need all those. You don't want that to happen. You want to use the right tool for the job, but you can't foresee everything, right? So it's all about the planning. And to your point, Santiago, you've got to understand if you're the consulting engineer working with a customer, you've got to be asking, you got to sit down with them, that company, and walk through all of their wants and needs to understand what you need to monitor and what data that you need and the accuracy. You might be able to, if you might be able to get away with a non, what do they call that? A non revenue accurate device if it's awareness and you're not actually going to be allocating energy. So if it's just an awareness of a ballpark figure of information, you could buy a less expensive meter possibly for that data point. And in some cases, our circuit breakers will have meters built into the circuit breaker, right? Doing double duty. So you've got to understand what the goal of the customer is, and then pick the devices. And the better that you do from a plan perspective, the less chances of that client saying, I want this, and you saying, well, you don't have that data, right? You know, like for example, if you bought a meter and it did watts, VARs, and VA, and voltage and current, and they said, hey, what's the percent THD for the harmonic content of this for this feeder? And you didn't buy that meter. And you said, well, why didn't you buy that meter? Well, it was a little bit more, but you never said that you were interested in power quality, right? So, and oh, by the way, if you put that meter on all of those feeders, your return on investment would have gone out another 6 years. You know, so it's all about trying to figure out what you need to purchase and where you need to put it in the facility and what you're going to do with it, in my opinion.
Sure. So I guess if someone was a facilities manager and they contacted somewhere, some type of electrical manufacturer, not to name any names, but where would they go to, who would be answering those questions that would best fit their needs? Who would they contact?
So what you would want to do, so there's a couple things, like, you're familiar with, and you're right in the heart of it. Our facility, we have an engineering services division. You wouldn't go to the product line. You wouldn't call a product manager. You would start with a local salesperson. Like if it was an Eaton thing, and I know everybody would just not go anywhere else, but from an Eaton perspective, you would get your sales office, get the sales engineer and an application engineer out there, explain what is what you're looking for, and then our services division will bring their talented individuals to the table and lay out a plan and go through all of these based upon their experience. Now, if it wasn't Eaton and you were going out to another firm, you're going to want to know what is the experience of that firm. It's not going to be just somebody off, who's a services group, right? Or does power analysis studies. There you go. It's it's not somebody who just like you take a company that does short circuit and coordination studies. They may not be in this energy management, although they might say, hey, yeah, we'll help you with that. But this is what happens. You don't have somebody who's experienced. And then you end up with what Santiago said. You get it all installed, and the customer says, all right, I got this new system. I want to allocate all of these costs and energy. And why is it that when I run my bill, it doesn't match the utility? Okay, because this has happened. I mean, I've been in this role and I've seen this, because I'll tell you where some of the issues come in. When you get down to it, you'll say, well, wait a second, what are the CTs you bought? Well, they're not metering class CTs. They're relaying CTs. Well, the accuracy is crap, right? So you're done. Yeah. You bought an expensive meter that's metering class, but you bought a CT you're using the same CTs that are for the relays, and now your current usage is so low that you're way outside the accuracy. Well, error number one, and then the guy will say, well, we just bought this whole system and I can't use it. Well, yeah, you didn't have the right consultation in the beginning, right? This is a huge investment. You need to do your homework. You need to have the right people sitting at the table. So that's the first thing. The second one was the wrong CT, not the wrong CTs, but the CTs were put in incorrectly. Reverse polarity on one or two of them. Okay.
Lovely.
All right. So, and if you have the right meter, you'll actually see that difference. If you look at the individual phases, you'll say, okay, something's wrong with phase A, and you'll find out the CT's backwards. Okay. So CT polarity, the wrong CTs, the wrong metering class that you're using, but you could have bought the metering class CTs. You could have everything done correctly there, and you bought a meter that doesn't have the accuracy that you need. Right. So then the other one, you gotta love this. Very large, heavy industrial. This was the first time, David. This is the first time. Imagine how many years you've been with Eaton.
I've been with Eaton for roughly 3 years now.
Okay, roughly 3 years. I was in the same situation, right? Application engineer, heavy industrial I was responsible for, calls me and says their energy bill did not match. They hit a peak demand.
Yeah.
Okay, set a huge dollar amount for the entire year for that entire company. They sent their corporate jet down, and me and the design engineer on the software were put on the jet. Okay, now here I am 3 years into Eaton, 5 years out of, so I was 5 years with a consulting firm, so 8 years into the industry, relatively new, 3 years to Eaton, right? I'm going on a that company's corporate jet to their facility.
You're going up Manny's Brothers' jet.
I'm on Permane Brothers jet going to their corporate headquarters. Okay. So we go in and now here's what I'm doing. And now I'm starting to realize the magnitude of the situation on when I'm on their plane, and my design engineer was Ming Lee. He was really nervous, and I'm sitting there like, oh boy, I've got to get my act together. So I'm going through all of their data, their raw database files, and their one-line diagrams. And before I got there, I realized they had 4 very, very large motors that weren't in their energy billing software. They had the data, but they didn't map it into their bill for the calculation. So I show up, we go into this facility, we go to a conference room, and there's a stenographer in the corner, okay?
Oh,
and
okay.
Everybody at the table has suits. And I'm like, oh boy, this is really serious. And then we sat down and they explained the gravity of the situation, meaning this is what this cost our company. And I'm like, okay, I get it. And they said your meters are not working correctly, your data, and they were going on and on. They compared the bills. They had slide deck up there, and then I showed them when you loaded those four motors in, and I explained they hit a peak demand because it was that situation where they had each of those 4 big motors were in 4 different parts of the plant, and they did a test all at the same time. And they set a huge peak demand for that entire year. I was sweating in that meeting. And when we got on, and once I explained it to them and we corrected the equations, we corrected their system, and they were happy as pigs in mud after that because they could understand what the problem was. So the first was they didn't know if it was the infrastructure, was it the meters that weren't correct, what was it? But here it was just data in the database and the wrong formula. So we went through a little training class after that meeting. Stenographer, folded everything up and left, and Tom was visibly sweating and nervous, and we came out of that one like rock stars because our data was, it was amazing how close we came to the utility bill once you put those 4 motors in. So, but that brings up the other issue is knowing what you're monitoring and making sure that your allocations, whatever software it is that you're using, and I know there's no other software other than Eaton out there, but you might be using an HMI like Wonderware or Iconics, or you might have a Johnson Controls Metasys system, and you're bringing data into there. So that whole profile and everything that you're doing with associated with that distribution system, the architecture of it, the data you're collecting, the accuracy of the data, is all critical data points that you need. So, but that was a that was an interesting development, but I
How
learned a
did
lot in that whole
how did your
process.
partner feel after you left?
He was, and Ming was the design engineer on the software. All right. So if there was anything, and what was interesting, here's what was really cool, was on the way back on the plane, he actually modified the software on the fly to provide even more value to the customer based upon some of this. So he made uh, changes to the software so that this couldn't happen to some in the future. They would
Yeah.
know that there was an issue with meters that weren't allocated inside the software. So, this is just one of those things where, and then for the next person who downloaded the latest version of the software, got that value, and then, it's just like anything. I mean, you buy an iPhone and then you get updates to it, and you see, oh, there's problems that were resolved in this firmware. Well, it's probably because David had a problem with his, called it in, and then I never had
Yeah.
that problem. You know what I mean?
Yeah, the new iPhone's out, so we can't have your battery last too long. So now we have to update it so your
That's
battery
right.
goes
That's
dead
right.
sooner.
Yeah, and then Santiago says, so used to call being on a private jet a big deal. Now he calls it Tuesday.
True.
Yeah. Oh my God. Back then we did a lot of flying around too, because I had large accounts and I was the technical liaison for a few large accounts, and they would always fly you
No
around.
big deal.
Yeah, it wasn't a big deal. Yeah.
Very
So,
big deal.
all right, so you got to have your energy plan. You got to know your equipment, your meters that you're putting in, and then you got to think about communications, right? So you have the physical layer. So you if you work your way back up through the system, you got the CT and the PT, right? You got a voltage transformer and a current transformer providing input to the meter. Then that meter has to be wired to something to be able to communicate to a computer somewhere, or a display like this one behind me, right? You may say, look, I'm not going to network anything. And in this piece of equipment, this big gray box, I'm just going to have a guy go out to this, or a girl go out to this piece of equipment, press a button, and record or email it straight from there to my information, to my inbox. Or it could be web-based. It could be that, hey, I go on my phone and I access that big screen there, and it gives me all of my energy usage for all of those devices. It could be very simple, but you've got to have the physical layer. RS-485, is it a twisted shielded pair? Is it a 10 base T, right? Is it wireless, right? So you have your physical layers you got to think about. And then you got protocols layered on top of that. Is it Modbus? Like, for example, I'm just looking like this one here. So this is one of our meters. Here's the communications. Okay, so this is the our metering product family, right? So this is the Power Expert 4000, and it does serial Modbus RTU, Modbus ASCII, Modbus TCP, Ethernet TCP IP. You can do HTTPS, which is your web browser. So it's a web browser setup and configuration as a web browser. So you have an SNMP, you have FTP. That means you can file transfer and you can take files out of there. DNP 3.0, another communication protocol. So you've got to think about what are the protocols. And then let's say that you bought our meter and by accident, you bought a competitive meter. I mean, it was like, oh my gosh, how the heck did that happen? I went on eBay and I bought it. Well, okay, so you accidentally put that other meter in this picture. Now, can you put that other manufacturer's meter on the same Modbus network as my meter, right? Or do they have to be both independent? And then you got to wire all that back, and maybe you need a gateway because maybe that competitive meter doesn't speak Modbus. It has a proprietary protocol. Now you got to figure out, how do I get that data back to this computer the same in a similar manner as I'm getting this Eaton data, which is Modbus RTU or Modbus ASCII or Modbus TCP. So So you have the physical layers. What can you put on the different? And then you got the communication protocols. What language does it speak? Okay, like Tamaki. Oh no, I might be in the same room as Tamaki, and maybe Tamaki doesn't speak English and I don't speak Japanese. So we need a translator. So you might need a communication box that communicates to both of those, converts that over, and pops that up. And then we have they call those gateways, and I know we have gateways as well. You know, and here's our PXBM. This goes into a residential type or a commercial panel board, and you can monitor each of those branch circuits. So, and with revenue accuracy. So you got to think about, what is it I'm monitoring? How am I going to monitor it? What CTs do I need? Do I even need CTs? What communication physical layer? How am I going to wire this back? Is it, am I just going to plug a 10 base T? And then if it's in gear, you can't just use any wire, right? You've got to use like a 600 volt rated. We called it blue hose. There was a Belden, man, I can't remember the number, 90 something. There was a specific Belden twisted shielded pair that we would use in our gear. They're probably still, which was the Modbus RTU, and it was shielded and it was rated 600 volts, so it could be used in gear. You just can't take any Ethernet wire and start wrapping it through there. You'll have data issues. You have all kinds of other issues. So you got to think about the physical layer, the protocols, and then the HMI. Wonderware, Iconics, or you're using an Eaton solution. Are you taking into a Johnson Control Medisys system? Are you taking into some other building management system? How do they communicate? So you got to think about, that's sort of like getting into the big picture from a system perspective. You got connectivity, and we're going to talk about connectivity this month too. I was big. I used to love the whole connectivity. We had different protocols and different gateways, and then there's timing issues. How fast you need the data, because sometimes you can get status changes. And we had some utilities. We had a utility that wanted a specific response time, so that when a breaker changed state, I had so many seconds for me to see that activity. And if you have a large system and you have a polling algorithm that goes through and it checks everything, I mean, think about it, it's a software application. If you have 5,000 meters or 5,000 metering points, you're going to go through 5,000 and then come back up to the top again. How fast does it go through that loop? And then does it take a minute for you to see a status change, right? And again, it goes back to what your goals are. That's why it's critical to know the goals of the installation. Okay. What else?
I think that's been a good introduction, to be honest.
Yeah, it was pretty. We went through, and I think the big focus today, from just setting the stage, is to understand your goals and objectives, understand get somebody involved up front to ask the right questions, and then figure out what equipment you're going to need to put in place and where, and then think about the communication layers, think about the protocols, think about the connectivity, and the data. Where are you going to put the data? How are you going to store your data? What are you going to do with that data? Because you don't want to just store data for storing data's sake. It's expensive.
I think we've been learning that lesson for the past 10 years through big data and everything else like that, right? We're starting to learn that it's not only just having the data and being able to have your lights on, but also it's finding the signal in the noise. I think that's what the phrase is nowadays. You have all this data now, you have to figure out what's actually telling you.
That's exactly right. And that's a big challenge, right? I mean, and to start with, you've got to understand what, if it's maintenance related, you're going to have a data set that you're going to be looking at that might not be the same data set that you'll need for, say, energy billing.
Yep.
So you really have to understand what your goals are. And then, power quality is in there too. Do you need waveform captures? All of these different things. And then what are you going to do with that information to say, I captured a waveform, whoopee ding ding. What are you going to do with it? Right? I mean, At the end of the day, you don't show your senior leadership, look at the waveform we captured. There's an abnormal event. Yes, please see here. Okay, right here. Here's what happened. Well,
They'll put it up on the refrigerator, tell you good job.
but that's exactly right. And oh, by the way, I could show you that waveform. I could show it to you right here. Look, there's the waveform. It's right here on my phone. Right? No, you have to do something and use it. So,
especially, I would say, even, with the rise of 5G, I guess, with it being such a topic, that bandwidth isn't even a problem anymore whenever it comes to capturing data. So you can start doing that real time over several entities, gathering data for everywhere on your facility. And so finding out the analysis of it really is the big deal. It's not even capturing it anymore. That's the huge challenge, because we have so many metering solutions, right?
yep.
We will figure it out for you, or at least ask Tommy Dmitrovich for a walkthrough or a minimum consultation or a maximum consultation, and we'll get you figured out. No problem.
I tell you what, though, I'm expensive, and if you're not like in Japan or in Hawaii, I ain't going.
It's true. He has a Permanis to run.
That's right. But if it takes me to the airport where I can get a Permani sandwich, because David, there is one in the Pittsburgh airport. Do you know that?
I'm going to need to hunt this thing down, because it's not like I'm not going out of the Pittsburgh airport. I just said, how have I missed it?
Oh my!
How is that possible? I know there's a TGI Fridays. I know it's right, the dead center in the middle, the center of concourse. I don't know how I missed the Permani. I'm ashamed of myself.
You should be. You should be. And you know what? Here's the other thing. Ryan Jackson is playing darts, and he has me on his radio. Look at that. I'm on his shop radio. He says he's playing this live stream on his garage toolbox stereo while he plays darts. I love it.
Man, that pop station must be pretty bad out there.
I'm telling you.
Picking up this.
Yeah, and what he's not saying is,
what radio station are we on, right?
He's also got my picture. He's got my picture on that dartboard. All right, so we're going to end this session with some references. Handbook of Energy Audits, Thuman. I already mentioned that, and this is an old book. It's the 5th edition. I don't know, but you know what? Energy hasn't changed much. Here's another one, Energy Management Handbook. This is by Wayne C. Turner. It's called the Energy Management Handbook. I found this a good reference for me. And then there was one more. Here it is. Here's another good Facility Management Handbook. And this has got a green thing to it. Look at that. Look at that. Now that's just too funny.
Both there, Tom.
I'm going to wear a green shirt one day. So this is a Facility Management Handbook by David G. Kotz, C-O-T-T-S. I tell you the truth, put it this way. There's not that many tabs on this one, okay? I've got a couple tabs on this one. I've got a lot of tabs on that one. So I liked the Energy Audit book more so than any of these others, because I think energy audits are really critically important to the success. And go in with eyes wide open, or hire somebody who has the eyes for you, right?
Eyes have it.
Eyes have it. The eyes have it. All right. So we went 6:26. Our 1 hour program went for 1 hour and 26 minutes.
Right.
And your feed was reliable. So good job in the feed. I can't believe
I don't know what to tell you. The lights were really trying to turn off in here. I don't know what to say. Maybe I can take this on the road and just start carrying you around different places.
There you go. Just that's not a bad idea.
But hey, the books, and we're gonna have Mike Stone on Thursday. Is that right?
Yeah, we're gonna have Mike Stone on Thursday, and we're gonna go over energy codes. So Mike Stone is on the Cal Green Committee. He's on from ICC codes, I think. And, well, we'll learn about how he's involved, but he is knee deep in the hoopla, so to speak. So he's knee deep in energy codes, really sharp individual, and it'll be a good introduction for all of those who follow my channel, the what the NEMA field reps do, who they are. So I want to make sure that everybody understands who, because those are important individuals and great resources for our industry. So,
Absolutely.
and then I got Tim Kraushaar, I think, coming up the week after that. Tim is used to be with, I think it was Allegheny Power, I think. And so we're going to talk connectivity, like a 705 discussion, an Article 705 discussion.
Okay.
And next week I got to talk to Mike Stone, but I'd like to also talk about some of the NEC Article 220 and a few other code requirements, like what you can put, like what meters and whatnot in 40. I think it's 406. Is 406 switchboards, panel boards? Can't remember. Is that 408? I think it's
I think
408.
406 is receptacle.
Yeah, you're right. 406 receptacles and 408 your panel boards and stuff. And then also in 3, is it 300, I think, that has the enclosures and whatnot, that we can look at what you can, like, can I retrofit meters into existing enclosures? So we're talking about the National Electrical Code along those lines. What are you laughing about?
And we'll find out if you can recondition this as well.
Yes, you finally brought it up. I still haven't. I got to create a stinger for reconditioned. I have to figure that one out. I got to create a stinger.
You left the
Yes.
door open.
Yeah, I did. I walked right into that one. So, but that could be a good. I do have. There's a person in our engineering division. I got a meeting with them, I think, this week to talk about retrofills, because that's another part of the energy management. 312.8. Thank you, Ryan. Section 312.8. We're going to talk about that and others requirements on Thursday as well. But there's another aspect that if you want to retrofit existing equipment and update, like say some of our breakers have communicating trip units, and you want to install the latest circuit breakers in that equipment. Maybe you want to change out a electronic trip unit that has metering capabilities, or update your system in that regard. What can you do? What can't you do? And what does we're going to bring? There's a division within Eaton that does that, our services division. So I'm planning to bring that person on sometime this month. But this is going to be an energy focused month. So we're throttling back a little bit on the safety message, and we're throttling forward on the energy message. And in some places they might overlap, and we'll talk about that. Make sense?
I'm looking forward to it. I want to thank everyone for coming on here tonight. Do not forget the very important thing: subscribe to the YouTube channel, follow Thomas Dimitrovic on Facebook, on LinkedIn. You might even have a Twitter.
Oh, I might. I'm streaming right now to Twitter. So everybody out there, you've got to subscribe and follow me on Twitter, because I never used the Twitter platform. And now that I found out that I can live stream, I only have 120 followers on Twitter.
Wow.
And I'm going to start tweeting. I'm going to tweet outside of this. Okay. Wait, what is that? What is that? Whoa. So I need to get more followers on Twitter. Okay. So get out there on Twitter and subscribe or follow.
What is your Twitter handle?
At T Dimitrovic.
There you go.
So is the @, T DOMITROVICH, at T Dimitrovic. Check it out. So that's my Twitter feed. And on LinkedIn, if you subscribe to LinkedIn, I'm going to start doing the stories. And I don't know if Twitter has that or not, but
I believe they have something similar. That sounds right.
Do they?
I believe so. Also, while we have everyone here, we always mark these with hashtag Eaton Tech Talk, and you can go and click on those, whether it's on YouTube or LinkedIn or Facebook, and you can find all of the previous episodes of Eaton Tech Talk if you missed anything. So you can go back and watch those, go back into the archives, and start being our historian. And you can start monitors all the things that I get wrong in these particular shows, including not having it for Manny's in Pittsburgh Airport.
You know what? We should have. I know what I'm going to do. I'm going to have a blooper award. Okay, so I've got to get an award, and that I can send you, and then I can share with everybody. Oh yes, we will. James Smith. We are going to be talking about return on investment and the cost benefit for energy management, and we touched. Again, that was a little bit of what we talked about today about you have to understand your goals and objectives. If you want a 10% reduction, if my energy bill is $100 a month and I want 10% reduction, I have to figure out if my cost of installing the equipment has, a 20-year return on investment, might not be a good idea. So we're going to talk about that cost benefit, James. So these are all good questions. And remember, June is National Energy Month. Act now. $29.95. Let's pick up the phone. Let's give us a call.
If this is for free.
Yes, that's right. And this is for free. So you're getting it here for free. But remember, now you got to start telling everybody else. June is Energy Month. Because our thought process about this, James, and Ryan, and Tamaki, if we keep saying it, it will be true. Right?
Well, it is true. June is Energy Month.
I love it.
That's what I heard.
That's exactly what you heard.
Today. That's right.
Okay.
Energy Month.
Loving it. I'm loving it. And you know what? I still only have 120 followers on Twitter. And we've talked about this, and I haven't gotten one more Twitter follower. I mean, I'm getting Twittered out here. So, James.
Thomas Diva Travis.
James, I'm counting on you, brother. Ryan, you got to go to Twitter, got to go on your phone, click on the little bird, see that little bird, and then you got to do search, and you got to search for @T.Dimitrovich, right?
Don't abuse our watchers who have lasted an hour and 34 minutes. Beg them for Twitter
if there's anybody who would do it, it would be these people who have been on here for an hour and 45 minutes. All right. We're going to close up shop.
I want to thank everyone for coming on. Absolutely. Thank you for everyone for listening. This has been fantastic. Yes. Thank you again, Tom, for letting me join you.
Thank you, David, for joining in. In November will be Torque Month. Newton meter November. I like it. I like it, Ryan. See, these are things. Look what I'm doing. November, Torque Month. And maybe we'll have a special guest, Ryan Jackson.
There you go.
Okay. Thanks, everybody, for joining in. I appreciate that. Wait, what's this? Hey, Tom, you should check if you could connect the comments on the different apps. I know Twitch allows it. In a way, it allows all viewers to view the conversation. Yeah, you know what, Santiago? That's a good point. The problem is, I have LinkedIn comments and all that. I'm not sure how to pull all that together. I'm going to research that. James Smith says he needs a class. Call me sometime when you have no class. Awesome. Okay, that was a Rodney Dangerfield one. Thanks, everybody. Thanks for joining Santiago, Ryan, James, Tamaki. Thumbs up, 2 thumbs up, subscribe, all that jazz. Thank you.
Energy Month.
Thank you, David Smith. Energy Month. All right, brothers.
Energy Month.
And sisters.
June. Energy Month.
Energy Month. June. Remember, June is Energy Month.
Energy Month.
Tell it to all your friends. Yep. All right. We're going to shut this feed down. So thank you, everybody, for joining us and sticking in. Felix Sandoval, Tamaki, on James, Ryan, everybody. Thanks for joining. Thanks for listening. Cheers. Take care. Stay safe. And please remember, stay healthy. All right. Signing off.
June is Energy Month. Dude.
June is Energy Month.
Energy Month. This one's right
it's
there.
Right there. It's right there. June is Energy Month. Thanks, Tamaki. Take care. All right. I'm hitting this end button.
Do it.